We are here to use our candy corn data set as an example of how to create a binomial probability distribution function, or binomial PDF, as we've been learning about. So what we're going to do right now, I'm first going to briefly talk about your challenge number 4, instead of immediately going into how to do this in Excel. I think it's from the last set, I have learned a few things, so I'm excited to hopefully improve these for you. So for challenge number 4, you will be using a different value, a different probability than I am using in my video. I'm going to be using our candy corn guesses to come up with a probability to use to create our PDF, and you will use this one to create your PDF. So as background for this, I read an article the other day that was talking about Google just released Gemini 3, which is an artificial intelligence model, and it's a very powerful model. And according to Google, the model is 72% accurate, which is a very big, that's really accurate for AI. So I also want to really emphasize to y'all, if you are using AI, please keep in mind that this is a huge thing, that this is 72% accurate. That means it's not accurate 28% of the time. So just keep that in mind when you're using it. Anyway, moving on. So 72% accurate. So what we're going to consider as our random variable here is we're counting the number of times we ask a question, and this Google Gemini responds with an accurate response. So you're not actually going to go into Google Gemini and do this. This is like a hypothetical. Again, with expected value, with PDFs, we are predicting things. We don't actually need to go and do it. Later on in this class, we will learn about comparing like real data to hypothetical data. So right now we're kind of in this hypothetical data realm where we're talking about like predicting based off of a probability we know. So what's going on is, like, hypothetically, we go into Google Gemini, we ask it 15 questions. And what we're counting is the number of times it responds with a correct answer. And if we're assuming that this is accurate 72% of the time, of course, there's a lot of variability with that. Like, what types of questions are we asking? Does that mean it's 72% correct with answers, or like the content? Ignoring all of that, we're kind of simplifying this as an example of a binomial distribution. So the idea here is that whether the response is accurate or not accurate, there is no in between. So this is binomial, and part of what you will be doing is talking about why is this a binomial experiment. So it's not because of what I just said. We've studied definitions of binomial experiments, what is required to make something a binomial experiment. So you're gonna have to explain, why is this a binomial experiment? And then what I will show you in these videos is how to create a PDF using these ideas, graph a PDF on a histogram, and then also we're going to use Excel formulas to calculate the mean, standard deviation of our probability distribution function, and then interpret all of this. So again, I will be using our candy corn data to model this, and you will be using this situation about Google Gemini 3. So I'm going to pause now and take us back into Excel where we will look at our data. And right now we're really just setting up what we're going to be doing for challenge number 4. So this first video is more of a setup. The next video will be kind of more of an instruction in Excel, what we're doing. Okay, give me 1 second. I'll pull up Excel. So here we have our original data where our real number of candy corns was 343. And so again, these are all of our guesses that you had. So in this video, again, we're really kind of setting up the binomial distribution idea, like why is what we're looking at a binomial distribution. After I get more, I'll give you more details in a minute. And then again, just setting up what this will be. The next video is where we're going to jump into more detail. So here we can look at a lot of different proportions or probabilities or percentages from our data. One thing we could do is look at, for example, the percent of guesses less than the real number. So let's say we wanted to look at how many people guessed less than 343. One way to do that we learned in our previous video. So I'm going to actually zoom in here. So I'm learning. Thank you for those of you who gave feedback that you can't see what I'm doing if I'm zoomed out that far. So one of the functions we learned was count if. So count if will count how many cells within a certain data range, if you're highlighting it, meet a criteria. So here what we're doing is looking at all of our data sets. So if you click and drag, so you're not just clicking on each, but you're clicking and dragging, like holding your finger down on the mouse, all the way down to get our whole data set. And then we can scroll up, come back over here. All right, so we want to count if these are less than 343. So we're wondering how many of you guessed less than 343, and we know that there was a total of 44. So what we need to do is divide. Let me give us more space so you can see. So we're taking the number of you, that's what this function means, the number of all of the guesses that were less than 343 divided by the total number of guesses. And that would give us the proportion. Oh, and it's exactly half. That's funny. So this is the proportion, not the percent. I want to be clear. We're going to jump into proportions in a future chapter. So this is a proportion, very similar to a probability. And a percent is what happens when we take that. So I'm going to type equals here to signify we want to take this. So a percent is if we take a proportion and multiply by 100. Something I didn't explicitly say in a previous video is that when you're multiplying in Excel, you have to use like the asterisk, like the star. You can't use X. Oh, that's a C. You can't use X as a times. It thinks that's the letter. So you do need to use the asterisk as a multiplication symbol for Excel. Okay, so the percent of guesses less than 343 is 50%. And in fact, I probably should have just calculated that there, but that's okay. I'll do this. Okay, so we could use that percent. That means exactly half of you guessed less than 343 and exactly half of you guessed higher than 343, which actually makes sense because our median was 344, if you remember. So because the real number was so close to the median, and the median is literally in the middle of the data set, it makes sense that exactly half of you would have guessed above and below. Okay, so maybe we won't use that proportion or that percent because that's, I'll say, not as interesting in terms of, I think 0.5 or 50% is a very common proportion that are used in statistics problems. So I want to use a different one. So how about we say maybe the percent of guesses within 100 of 343. So we're looking at how many of you guessed within 100 candy corns of the correct number. So let me zoom out just to highlight this data set. So 343, lower bound, upper bound. I'm going to come up with the region we're guessing, like that we're looking within here. So we're looking at, and I told you I would zoom out, but now I'm doing a formula. So let me zoom in really quick. Okay. I'm wondering about 343 minus 100. So I'm looking at like between 243. And then I'm going to do 343 plus 100. So I'm looking between 243 and 443. So how many guesses were between those two numbers? So I'm going to come over here and highlight them. So 243 would be, we don't have that, but it goes from here. And then to 443 would be here. All right. So let's find this proportion. So to find this proportion, what I'm going to actually do, instead of doing the count if and typing in a bunch of conditions for this, which can take some time, what I'm going to do is just do the count function and highlight the cells that I have highlighted here. So equals count literally will count the number of cells you're highlighting as long as they have a value in them. If you're highlighting empty cells, it will not count empty cells. Okay, so then click and highlight here. So we have counted how many of you guessed within the range of 243 to 443. And I want to divide that by the total number of guesses. Okay, so the proportion is about 0.295. So if we want to make that a percent, again, what we do is we can type equals in Excel. And then if we can just click on this number instead of like retyping it, times 100. I will point out too another thing you can do in Excel, which I'm showing you the calculation because I think it's important. But in this cell, if you were to come up here and click on this percent, it will automatically change it to a percent. And I've seen in another, I mean, I've shown you in another video, you can change the number of decimals by doing this as well. But for now, I am keeping them separate because I think it's important to look at them as separate values right now. So I will make this rounded. So we'll go with 29.55%, or the proportion of 0.2955. So what we're going to be considering now is, we're essentially using this proportion as an idea of like, if we were to go sample other people, about 29.55% of people would be within 100 of the correct guess. If I just went out and randomly surveyed a bunch of people on campus where I live, wherever, about how many candy corns were in this jar, we could, within reason, assume that about 29.55% of them would be guessing without 100, because that's what happened in this sample. And this is kind of what statistics is about, is that's not necessarily true that the exact thing will happen. And in fact, we could find other samples with very different proportions here, depending on who we're asking. But statistics is really great to take a data set and then kind of generalize what's going on with that data set and predict what would happen in another group of people. So our situation here, in our next video, I'll talk more about what we're doing that represents a binomial distribution. But I wanted to show you how we came up with the proportion we're going to be using in our videos moving forward for this analysis. So we will be using this proportion of 0.2955 with our binomial experiment. And I'll see you in the next video to talk about how do we make this PDF from here.